Hey everybody, this is Larry. This is me doing an extra problem before 8 p.m. There's only actually a couple minutes, but we'll do the daily problem afterwards. But yeah, I today it's very hot here in New York. It is still 90 degrees, and I am just going to try to do problems before I go for a run because now I feel good, but before, I don't know. I feel like I've just been doing a lot of these videos, a little bit tired to be honest, and I don't know. It's just not ideal, honestly. But we'll see how things go. But it's just I don't know. My computer's also being so slow. So hit the like button, give me a little bit of support, and yeah, let me know what you think. Still training for the marathon. 87 days to the marathon. So I'm very excited. Um, if these things want to load. That would be nice. Make it a little bit faster. Maybe it's my computer. I don't know. Sometimes it looks like this. But all right. So today our random problem is 360 sort transformed array. Given a sorted integer nums and 300 a, b, and c, apply a quadratic formula of a squared, ax squared to each element, and then return the array in a sorted order. Okay. So I think the thing that I had to peek at the constraint is that this is in ascending order, right? So because it's in ascending order, it does make it easier to do in a sorted order. Keeping in mind that quadratic formula, if you just kind of recall, then it is going to have like a parabola, right? It's going to be parabotic in some direction, right? So what that means is that there's going to be peak and unpeak, right? So I think the naive thing that you can do, or probably the first thing you could do, is just calculate it for each number and then sort it, right? However, because of this parabolic thing, that means that you can kind of find the middle and then kind of merge, or like do almost like I said merge because I meant that in like almost like a merge sort kind of way, right? Let's do the sorting idea first, just to make sure that we get it right. And then yeah, so then now we have f. Let's just have a f of x, and we just return a times x plus b times x. And you could actually use what you might call it. What is that? Is it Turners? No. I'm blanking out the name, but you can write it in this way is what I mean. Where it's just c plus b times, oh wait, no, it's a times x plus b, right, times x plus c, right? I think it's called Horner's, right? Like, am I making that up? Yeah, Horner's rule, right? So it's like almost like a shift and add, right? So yeah, I mean, it's just also something to kind of, or is it rule or algorithm? I don't know, or method maybe. I don't know. Just Google this. It's slightly faster. I mean, obviously not that much, but maybe more important back in the day where computers are much slower than and nowadays especially it's not super clear anyway because a lot of things are done in parallel. So yeah. But in any case, it is like a shift and add thing, right? And it's just a little bit nicer to look at. In any case, yeah. So then now we can just do, yeah. Let's say f of x is equal to just for x in nums, we have f of x, right? So we have this is a list, and then we can also sort it. And actually that's it, right? We don't even need this f of x. We just return this and we are good, right? In theory. But yeah, pretty straightforward, right? I mean, this is gonna be n log n because of the sorting. Everything else is pretty straightforward too, at least in terms of looking at it. The thing I was gonna say is that, as I said, it's gonna be parabolic. It's a little bit, I mean, you can do it in linear time. It's just a little bit nuanced because it depends on the A, right? So that, I mean, if you, and this is off my head, so maybe I get the direction wrong. So forgive me if I, mix up which one is which. But for example, the A, if it's negative, then it goes this way, right? Meaning it has a peak. And you can actually just like print it out really. So it's not, right? Yeah, so then you can see that, well, actually, I guess it just never goes to the bottom top, but, like, but if you keep on going, one goes up to 200, right? You can see that for negative a's, I mean, this is like very high school, this high school math, right? That you can kind of rederive and figure out from scratch, kind of like what I'm doing here. And if it's a positive a, then as a low point, right? So that means that, you know, to do in linear time, it is relatively straightforward in a way. Yeah, it's basically okay. So, I mean, I'm just gonna write it out. You could probably write it in a way that is I guess when a is equal to 0, I'm just thinking about when a is equal to 0, it's a little bit awkward because then you just have a line, right? But yeah. Okay, so oh yeah, fx is equal to, let's say, this list, right? So then now we have maybe 3 cases. We'll skip a. If a is equal to 0, then we'll skip this for now, only because I mean I know how to do it. It's just we've been talking about it. If a is positive, then you have this case where you have like a parabola where you have a minimum, right? So then now we just find the min, and here I think I want to extend the inputs a little bit more. Actually, use this as well, right? And you, oh, I don't actually. Okay. Yeah, you can see that. Okay, you cannot see that because I think we have to go more negative. Maybe something like that. Right? It's still. Is this right? Why is it 290? Oh no, that's just. Oh, because I'm already sorted. That's why. I don't mean to sort this. That's why I got confused. Okay, yeah. So then now here, as you can see, it does this curve thing, right? So then now what we want is just to get the minimum. So maybe we have, you know, smallest is equal to min of fx, right? And then we just get the index. So middle is, smallest index is equal to fx dot index of smallest. Maybe you can win this in one line, I suppose, but either way. But both of these are linear, of course. And then now it is just a merge sort from the middle, right? So then maybe you can have results is equal to right? Yeah, and maybe I'll just do a helper function actually, right? So like here we get we order from smallest index, right? So then you just maybe go outwards from here, right? And then if else if, which either way is fine, right? Then largest is equal to max of fx, then largest index is equal to fx dot index of largest, and then we can just return also reorder of largest index, right? And then else, which is a is equal to 0. We'll do what I mean. I mean, this is just a merge. I mean, it's kind of like a merge sort, but you just kind of, you know, go out, right? Which is a little bit awkward, but that's why we have a helper function. If a is equal to 0, then you have a line, right? There's no parabola, it's just a line, and then it's just a vertical line, or I mean, sorry, not a vertical line, but a line with a positive slope or one with negative slope, which is determined by b, right? So if b is greater than 0, then the smallest element is going to be in the this reorder thing is a little bit awkward. Maybe I have to be a little bit clearer, to be honest. And also I forget to turn it fx, right? Maybe it's a little bit unclear. Maybe I have to do a little bit more about it. But yeah, but when b is greater than 0, then the smallest element is the first element. So you can just say reorder fx 0, right? And then else well, if b is equal to 0 or otherwise, then we it's a little bit awkward the way that I think I need to add a parameter to determine which order to go, which way to go, right? So maybe here, if it's positive, then it's go increasing. Yeah. I mean, you could do things. I'm trying to also keep it simple because I don't want to like the idea that I'm having is just like passing a lambda function or something and then use higher level programming on it. But that's probably too crazy. So let's just actually go. We order small or like small to large, and then we order large. Let's just have two functions, right? It does not you know. It's not as clean as I actually thought I would have it, but it's fine. I just want to illustrate that illustrate. So then here, basically now index is the smallest. So then now we want to keep it in a smaller element, right? That's the thing. And in theory, you could pass a function to kind of do this, so that it's a little bit more dry, like not repeating yourself. But I think that's like, you know, especially if you're a beginner, it's a little bit too wonky. I just thought to read, but yeah. What am I doing again? Oh yeah, yeah. So then now we have an answer is equal to num sub index, right? And then we have two indexes. Left is equal to index -1, right is equal to index +1. Then while left is greater than equal to 0 and right is less or greater than equal to n, I guess we need n. Then now we take the smaller function to use, or the smaller thing to use, right? So if num sub left is smaller than num sub right, then we take the num sub left, right? Dot append num sub left. We make it smaller, else take num sub right. And then, oops. Yeah, very standard merge sort looking things, right? I guess this is more like two pointers algorithm really. But yeah, and that is just small, right? And then here, okay, so then now you have, oops, so you have this, and then now we can copy and paste this, and I'll do the refactor in a little bit just to kind of give you a glimpse of what I was thinking of, but I thought that it may be a little bit hard to read. Is that, okay, now then we just, that's it, that's the only thing that changes, right? Okay, and it's also wrong. Oh, that's because this is not num sub. This, I don't know why. Okay, fine. I'll just put it here and this should be fine. But what is wrong about this? Oh, this is in reversed order for some reason. Well, the comment is wrong. But did I right? So you have the largest index. If this is greater than, oh, I'm dumb. Because if it's greater, you're still outwardly looking at it, right? But then now you have to reverse because I was expanding it outward so that now it gets the biggest number first. Alright, I mean, you can actually do it the other way with just like merging from the edges instead. I think this is actually a little bit cleaner, but I don't know. But yeah, so give a submit, make sure that is right? So that's basically it. That keeps it linear time, but of course due to the additional complexity, I guess it just ends up being slower. You can actually combine these into one function. Maybe you can have something like f, right? And then now just f of right, and then f of right, and that really would be it. And then we just have to remember to use, well, I guess we don't have to use this here. We don't need this anymore, right? So like for example, that's one way that you can refactor this. And here you just now you need to take a smaller. I think there's like I don't know. But yeah, maybe you could do like less than, right? So def. I mean, I'm sure this is a thing, but which is just return a is less than b, right? So then now we can do less than, and that should be good. And then here maybe we could do greater than, and which is the same idea. Roughly speaking, I mean, maybe you can also write it the other way where you use less than, but yeah, yeah. You have to remember to inverse this stuff. Sometimes I forget. I don't know why. I've been really bad about forgetting stuff. But yeah, so then now here we reverse this. And we should be good. In theory. Yeah. Give a spin. Oh, one time error. Cannot accept. Did I mess this up? Oh, because I copied and pasted. Whoops. That was just me being lazy. This should be 0 as we kind of, you know. Let's put this in here. but you know, this is why when you refactor, this is why TDD works, right? So that you see your errors and you're like, oh, okay, yeah. So yeah, very you know, very good way of doing it, right? So here, then now you just have this function, and you see that it only changes here, right? What else can we do? I mean, I think you can also, like I said, merge from the outside, but that's even more complex. I mean, and not that much more complex, it's just code, right? But yeah, just playing an idea. Anyway, yeah, just want to show you my code one more time, but that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.